A very good afternoon to all. Infrastructure is the backbone of the nation, including industrial, agricultural, as well as international and domestic commerce, as we all know. It is required to increase the productivity and seamless functioning of the business sectors with holistic growth of the nation. Good infrastructure is essential not only for economic growth, but also for inclusive growth. But in the era of this growth, sustainability often takes a backseat. The impact of efficient infrastructure accounts for a significant reduction in carbon footprint throughout the life cycle, making clean, sustainable development a top priority. Which, with digitization and modern technologies available, we are taking steps for sustained growth economically as well as environmentally. With this, we shall start with our final webinar on tunneling in infrastructure projects for sustainable corridor planning and modeling series. So coming over to our agenda, we shall start with a company introduction by Mr. Shitanshu Jain, Regional Sales Manager, AEC Infrastructure, Capricorn Technologies, which shall be followed by an introduction to BIM for infrastructure by Mohammed Sohaib and Abid. It will be followed by tunnel project demonstration using AEC suite, continued by station building development and demonstration. Then we shall focus on cloud-based common data environment using ACC by Riddhi, which will be followed by a question answer session and ending with vote of thanks. I would like to request all participants to keep on writing their questions in the question and answer box. Now, I would like to introduce and invite Mr. Shitanshu Jain, Regional Sales Manager, AEC and Infrastructure, Capricorn Technologies, to take over, sir. Over to you.
Thank you, Naman. Just confirming if I'm audible.
Yep, you are, sir.
Yeah, thank you. A very good afternoon to everyone from the industry, that is design and construction. I'm Shitanshu Jain, part of the construction and the design focused technology adoption team here at Capricorn. And my personal belief is that in this decade, between 2020 and 2030, is going to be the decade where technology adoption is going to be massive in construction. So till now, it has been primarily in a lot of our corollary industries like manufacturing or IT for that matter, no doubt, like banking, even to an extent agriculture also. But construction is one of the laggards in technology adoption. And this decade, I believe construction needs its due and would adopt technology like we have never seen in the past. So with that, the second main criteria in construction with technology adoption would be around sustainability. So we are seeing the effects of climate change every day, today, yesterday. It's there in the news everywhere, and we are not no more. We are not affected by what is happening in the environment around us. And now the question is how we are going to what we are going to do to stop this this kind of impact which we have done through development over last 50 years, 50 or 60 years, which is even, I would say, nothing has happened like that in over last 5,000 years. So what we are going to do now will impact our future generation, our kids, and what kind of world we leave for them is something that is in question today. So with that, I will just give a brief introduction about who we are as Capricorn and what we are here to do. Naman, can you move us one slide back, please? Yeah, thanks. So as Capricorn, we have been part of India's technology and AEC industry for more than 30 years. So we have been present since 1987, helping organizations like owners, the government organizations, contractors adopt technology and go through a digital transformation in their design and construction processes. We are heavily focused on providing solutions for the AEC industry and present across India. So the Delhi, Mumbai, Hyderabad, and Bangalore, we have physical offices. And apart from that, we are supporting our customers globally through remote. With that, now a big change has come into Capricorn. Number next slide, please. So now we are a WinZero company. So WinZero is a global alliance of companies present out of UK, US, Australia, and India. And with this, we have a global expertise on solutions for AEC industry. And we would be bringing some of the more mature technologies and services to the Indian shores. And so that is one of the ideas of Venzero. Of course, sustainability being the core factor, how we can be more sustainable every day in our projects, in our processes, as an individual, as an organization, as a nation, etc. So the idea here is that now today's topic is around specifically around how tunnels can be designed using multiple technologies. I'll shed some little bit light on that. So India has announced about 1.5 trillion worth, $1.5 trillion worth of projects which are to be executed over next 5 to 10 years, which mostly are more in infrastructure side like road, railways, metros, waterways, and most of these projects would have tunnels in some form or the other. And nowadays, from a customer experience, from our industry talks, we have realized that tunnels is one such that the design is not design is quite critical and design is quite difficult using standard CAD-based tools. So today we are going to demonstrate to you how the design of design, modeling, all of that tunneling part of these projects can be to a certain extent automated, and you can have more of BIM-based design, which can then help you in having a better control over your projects. So with this, I would like to hand it back over to Naman and take us through the technical part of it. Naman, over to you.
Thank you so much, sir, for the rich introduction. Now, heading over, I would like to invite Mohammed Shoaib, BIM specialist in architecture, and Abid, solution specialist in Civil 3D, to start with the technical presentation. Over to you guys.
Yeah, thank you, Naman sir. So before start of this session, we would like to have a small poll, audience poll on top of BIM, like what actually BIM stands for. And there are a couple of questions. I think Mr. Naman, if you can publish those questions. Yeah, if you can quickly answer this question, what actually BIM stands for, whether it's an infrastructure model, an intelligent model, or maybe an information model. I have already seen most of you have actively participating in the poll. Request you everyone to poll on the question which has been posted. BIM stands for Building Infrastructure Model, an Intelligent Model, or Information Model. I have received almost, I think 70% of the participation. I request you to everyone to go and okay. So I have I'll be publishing the poll now. Like most of you have voted as a building information model. I think around 87% of the people has voted as building information model, and around 13% of people are voted as building infrastructure model, right? So with this, I would like to move another question. We have one more question for BIM. I think Mr. Naman, if you can post another question. Yeah. What is BIM? Like if I request to participant again to poll on this question as well. What is BIM? Whether it's a software, technology, process, collection of data, or maybe all of the above, you can give your answers in the poll box. I can see the 55% people are already voted. Most of you are voting all the above. Collection of data, process. Is it a technology or software? I think a couple of people left. We'll be ending this poll in 15 more seconds. We'll request the audience to participate on the poll. Okay. Okay, I'll be ending the poll right now. Like I have received a lot of answer from here onwards. Mr. Shoaib will be taking it forward. Shoaib sir, over to you.
Hello, thank you, Abid. So I'll share my screen.
Yes, please.
I think my screen is visible.
Yeah, it's visible.
So after audience poll, so from audience poll, we got to know that most of you already know the full form of BIM, that stands for Building Information Modeling. But about what BIM stands for, most of you already know that it's all of the above options which we posted in poll. That is, it is also about collection of building data, but with the help of technology. And by using this technology, we actually set up a process to deliver a project more efficiently. So if I go for official definition, building information modeling is a digital representation of a physical and functional characteristics of a facility. And we are not limiting this to a building. We are actually taking up any built environment or facility which is built on site. So before creating any component, we actually also in manufacturing and in building industry also, we tend to create a prototype for it. And to create that prototype, a digital prototype, we actually require a modeling tool. And that modeling tool should be sufficient enough to put up all the project related information in it. And the process of this is known as BIM. And this definition is actually given by US National Building Information Model Standard Project Committee. So it's a standard definition. So first part of the BIM is that it's a digital representation of a functional facility. And here I would like to also discuss about that the terminology building here in building information modeling is not used as a noun. So we are not actually talking about a single building. Here the word building is actually used as a verb. So if I find out some synonym and for building as a verb, then we may replace it with creating or maybe developing. So we are basically creating or developing or building an information model. So we are developing a model where all the information is stored. So once a digital prototype is created in the form of geometry, components, spaces, materials, occupancy, performance, or other parameters, once a digital prototype is created, you can get output in terms of analysis, maybe structure analysis, or maybe HVAC analysis or energy analysis. You can get simulations also, such as 4D simulation, which can be used for later for construction management, or maybe some other types of simulations such as HVAC simulations and different simulations. I mean, compliance check you can do here, like you can get different information of different compliances which are used. You can also add life time of the compliance also. For example, if a duct is installed in a project, then you can also add its lifetime with that component. So for example, if that duct has a warranty of 2 years or 5 years or 10 years, for example, then you can then that model will generate a notification to operation maintenance team later, and that component can be changed or can be repaired at the time. That is what compliance check means here. Then you can also explore model in 3D because it's a byproduct of this information model. You can also optimize changes, whatever changes you find out after clash detection and all. You can also run operation maintenance, like I already mentioned here. Second part of BIM is once we get a digital prototype or a digital model, it would become a shared knowledge resource. So that digital prototype can be shared with multiple stakeholders in a project. So HVAC team, MEP team will be working on the same model at the same time when architects are also updating the model. Similarly, civil engineers, mechanical engineers, electrical engineers, all or maybe other consultants also can update model at the same time. That is how cloud work sharing works. So you can just create a digital prototype and then can share that on cloud, and at the same time multiple stakeholders can work on it. So it's a shared knowledge resource. It's a resource which can be used by multiple people. And accordingly, during the life cycle of the project, the same model can be used. So from the inception or the programming stage of the project, where we lay out area plans, we lay out concept of the building or concept of a project, to the analysis stage, to the detailed design documentation stage, to the construction stage, and then later on for operation maintenance. And if, for example, building life cycle completes, then building can be further renovated or maybe demolished. And during that phase also, this same model information can be used. So same model cannot be lost after construction. It can be used post-construction activities also. That is the whole idea of it from the inception of the project. So key concept of BIM, if I talk about, we basically, what it basically gives us a single coordinated model, a model which is coordinated, like multiple people once, updating that model. At the same time, it updates on cloud and everybody can see the changes. So it's a coordinated model. This example we have taken from, one of our, tunnel projects. So as you may notice here, this tunnel has multiple services placed in it, like lighting services, conduits are going on, pipes are going on. So this is one of the screenshots of it. So it gives us a single coordinated model. Multiple people are working on it. Civil engineers are working on its shape of the tunnel. Mechanical engineers are working on their lighting layout and electrical layout, and so there are fire safety layouts. So it's a single coordinated model. Who can work on it? Like I already mentioned, designers team, engineers team, contractors team at the same time can work on it. That is the beauty of BIM. Similarly, how it works. So answer lies in the single coordinated model. So it works because it's a single coordinated model. It's a single source of database for everyone. So my truth, we call it single source of truth. So my truth will be same as the truth of any other team also. So everybody would be on the same page. Everybody would have the same version of the file. So there will there are chances of data losses are minimized in this case. And when can you work on it? Obviously, I've already mentioned this, from the design stage to the construction stage and post-construction for operation and maintenance also. The same BIM model can be used. So what do you think is the most important stage in building life cycle? Obviously, I've written down some areas also. So suppose for designing a building or maybe in this case tunnel, you would require, let's say, half years of half, or let's say 6 months of the time, or maybe sometimes 1 year of the time. Then construction might take 3 years to 10 years to build. For example, if it's a complex project, maximum 10 years would be fine, I guess. But for operation and maintenance, that project once built on site would take 80 to 100 years of time. So, to make that project more sustainable is the need of the hour. So basically, for a client, the cost saving lies in the operation maintenance stage. So whatever he spent on design and construction would directly affect the operation maintenance stage. So for example, that person, if tries to save some money in design stage or maybe construction stage, that directly affects the operation maintenance, because operation maintenance is the longest stage, and that is why BIM comes in hand here. So once you get a digital representation of the physical facility, once you get a digital prototype, so whatever components you are placing there, be it electrical component, mechanical component, because once civil part is done, then obviously maintenance will be done for MEP components most of the time. So for piping, for plumbing, for HVAC components, for fire safety system, it needs to be maintained throughout the life cycle of the project. And operation maintenance team also track those changes by using a BIM model. So we also add life cycle of every component in a BIM model. And once that life cycle is about to complete, BIM model is connected with operation maintenance software, and it automatically generates a notification, and that notification can be taken out, can be registered by operation maintenance team. So to make projects more sustainable is one of the goals, and to make it more sustainable, there are some active design measures and some are passive design measures which can also be implemented. So anyways, we'll discuss about more further about sustainability. So these are the kind of projects which can be handled in Revit, in BIM. So from here, I would like to invite back Mr. Abid. Abid, over to you.
Yeah. Thank you. I'll share my screen. Yeah, as Mr. Shoaib mentioned, the building information modeling is not only limited to buildings. So most of the people, like whenever we used to go and interact with most of the industry, like the people who are working in industry, they always things that like their perception is it's only limited to building. It's only limited to construction of vertical structures. So as I mentioned, like as we are showcase some of the projects, building information modeling is also not only limited to building, it's applicable for a lot of infrastructure projects. So we as a Capricorn have helped a lot of organization to implement BIM. So for an instant, I have added couple of snaps over there. You can see like there is a road project. So road and a bridge project, I should say, right? So over there also you can use building information modeling, and there is a railway corridor project which has been showcased. So building information modeling can also applicable for road and rail projects. Apart from that, you can see the piping and network projects, and I haven't able to add more snaps on top of hydroelectric projects. So we as a Capricorn now working with the consultancies and the firms in hydroelectric projects, we have implemented a lot of stuff over there. Also we can use building information modeling, right? So with this, I would like to shift to my actual presentation on top of tunnel project workflow. So very first step of the tunnel project, or maybe any of the infrastructure project, like we'll start from the preliminary phase of preliminary level of phase, right? So over there we need to capture the existing site conditions, which is one of the major agenda, because as of now in industry, when you go and work on any of the multidisciplinary project, you don't have information to build on. Or maybe like we are working with some of the consultants. So what they are doing, they're actually working on a 2D base map. Either they purchase those 2D base maps from NRSC, or maybe they will purchase some of the data from some other external mapping agencies, or maybe from external agencies. They're getting the 2D base maps. So they're now, or maybe most of the organizations also working on Google Earth. So they take help from the Google Earth. They identify that particular project location, and they'll use some polygon and shape creation tools, and they'll identify an alignment where to draw, right? So agenda over here is, and what I am trying to explain to you guys is, the workflow is more like a 2D based environment. We don't have a 3D constrained environment with us, or maybe, you know, some of the organizations are doing preliminary kind of survey. They're getting that information. Most of like their survey team is going to the survey area or project area. They are doing preliminary kind of survey, and they're taking most of the project information with them, right? Later that information need to be conveyed to the engineer or designer. Then that information is going to be simulated digitally, and he start working on it. So there's a like there's a lack of time and lack of the design data we have, right? So like the workflow which we recommend is more over a connected environment in BIM with the help of Autodesk InfraWorks. By specifying a location, you can actually capture a terrain conditions. You can actually capture the existing site conditions, including the buildings, the area, the roads which we have. That information has been captured by the Bing Maps. So Autodesk InfraWorks has direct integration with the Bing Map. You will get that contour elevation data from the USGS satellite servers. Now, the data which we have, like which we captured, is more like a digital elevation model. We actually get a 3D contour information in it. Although it's for preliminary kind of data, that is accurate. So like obviously we are capturing from the satellite servers, and it's a open source platform. Data accuracy may not be 100% accurate, but for preliminary kind of preliminary level of design, to understand that particular site condition and to estimate the project value, the data which we receive is more handy. More like we actually work on a 3D environment, right? So with the help of InfraWorks, by specifying an actual location, you can build your complete terrain model. Then that captured existing terrain data can be exchanged with Civil 3D, and you can further do modification on top of terrain. Like if you want to do some sort of terrain analysis, and you want to do some sort of site analysis, and you want to understand the low and high end points and the drainage conditions of that particular site, you can exchange the information to Civil 3D, and you can perform different types of terrain analysis on top of it. And even you can extract the contour maps of that particular area. You can do that as well. So as I mentioned, in preliminary kind of survey, preliminary level of design, we need to capture and build the existing condition. With the help of InfraWorks creation tools, actually you can propose your road layers. As you can see, I'll also show you this particular project which we worked on. There are a couple of tunnels are going, right? So these are the tunnels which has been proposed by us. Right, this kind of modeling can also be done in InfraWorks. Then you can share this complete information, the road layouts which you have proposed, or maybe the rail layouts which you have proposed. That information you can exchange to Civil 3D. So since the release of 2018 version of Civil 3D and InfraWorks, they specially worked on the integration or data exchange part on it. So when you have Civil 3D 2018 or earlier versions, or maybe 2019, 2022, 21 to 23 versions, so you can directly exchange information from InfraWorks to Civil 3D. The information which you got, the design, the preliminary kind of design you did in InfraWorks, complete information is going to be exchanged to Civil 3D. Over there, we can do the detailed road assembly modeling. For instance, I want to modify a lane from 2 to 4 lane, or maybe if I want to do complex assembly detailing, that kind of information you can model in Civil 3D. Then you can run entire alignment which has been proposed. Right. Again, with the help of Civil 3D, you can do the detailed documentation part. For instance, you want to extract different types of cross sections, or maybe if you want to extract different type of profile information on top of it, right? Or maybe you want to do the hydro analysis, and you want to do the drainage design on top of it. You can exchange the information to now even Autodesk acquired the Innovize for $1 billion. Now Civil 3D had its own plugin to exchange the information from Civil 3D to info drainage. Over there, you can do detailed flood simulation, detailed flood drainage design, right? Then you can bring that information back to Civil 3D, and you can do detailed quantity takeoff even in Civil 3D, right? So that is something is available with Autodesk AEC project suite, right? So later, the information, like as you have seen earlier, that information has been captured and modeled in InfraWorks. With this, I'd like to switch to a live demonstration rather than a complete PPT model. I'll open my InfraWorks tab. As I mentioned earlier also, I can easily capture the information by sitting in my desk. How? With the help of InfraWorks Model Builder, by specifying a location. Like if I give an example, for example, if you're traveling from A location to B in a Google map, you will search a location, right? Same way, either you can specify a location or you can specify the coordinates. By sitting in the office, you will get a 3D detailed terrain model ready on your desktops, right? So imagine how much of time you're saving in terms of preliminary kind of design and the visualization which we get. Right. So when we are working in a 2D base map, you won't have that kind of visualization comparatively that Google Earth and some other tools, some other AutoCAD drafting tools, or maybe you're using some other 2D based workflows, right? Over there, the visualization is something which is, very tough to imagine. Like, see, you are going for approvals, or imagine in this way you are going, you did entire design in a 2D based workflow. Now you are going for an approval to a higher authority, right? Higher authority may not able to understand, because the ministers who are working, they don't have a technical knowledge. They can't able to understand by seeing in those 2D based drawings. So when you do modeling in a 3D based environment, like InfraWorks allows you to capture the data in 3D environment, and it will allows you to create and propose your design in a 3D based manner. So it helps the design engineer to understand the details of design. And also we are working in a 3D environment, so we can do and improve the visualization. In terms of visualization, you will get a beautiful rendered model, right? So with the help of InfraWorks, you can go further. You can create your storyboards, including your company logo and information. That information you can take, like you can present to higher authorities, and you can get easy approvals, right? Apart from that, you can also use for some marketing and purposes. So as I mentioned, with the help of InfraWorks Model Builder, by specifying a location, you can capture the entire site. For an instant, I would like to search an area of Navi Mumbai, or maybe I will take an example of Jaipur, right? I'll search Jaipur. I'll take a Jaipur, Rajasthan as my reference data. Now you can see that area has been zoomed out, right? as you can like as you searched in Google Earth or Google Maps, same kind, by specifying the location, you can actually zoom that particular region, right? So as of now, I'm in a road aerial view, road view. On top right hand corner, we have an option to switch an aerial view. I can switch to an aerial view. Further, I can zoom in that particular region, right? After zooming in that particular region, for an example, I want to plan a connectivity road from Pratap Nagar to some probably this national highway. This national highway, I want to create one another road, right? I want to capture this particular site area. Still, I have a idea in my brain. By sitting in office, I'm trying to capturing the entire site conditions, right? For that part, like InfraWorks have their own tools to capture the area. Either you can specify a rectangle, you can define a particular shape, or maybe if you have any polygon boundary already drafted, you can import that polygon boundary and you can capture the entire area, right? For an instant, I would like to capture this much of area. I can specify the location. After that, you just need to specify a model name and the coordinate system, and you will get a 3D model ready with you. I'll open one of the project over there. I have already captured my site area. You can see this is the area of information which you can capture, the existing site conditions, the river which you are getting, and the hills, right? Different types of thing. And more of now, as I mentioned, I will get a contour information with this particular model. As you can see, it had a 3D model. It had a 3D hills which I can see, right? It means there is already a contour information, or maybe elevation information is already available in this particular model. If I switch from a conceptual view to an engineering view, you can see that information as well, right? I'll switch to an engineering view. I'll just show you. You can see that contours which are created, right? The contour information, you can see this kind of contour information you can exchange to Civil 3D, and you can do further more details on top of it, further more detail engineering, right? I'll switch to my presentation back again. Over here, probably. Yeah. So as I mentioned, with the help of InfraWorks, you can do the conceptual tunnel modeling. Then that information can be shared to Civil 3D for detailed design of assembly. You can, take an help from subassembly composure of Civil 3D. You can further do the complex modeling of tunnel design. That tunnel design can be run across the alignment which has been proposed, right? So apart from that, the model, the data, the information which you have created can be exchanged to Revit for the detailed tunnel modeling, or maybe for the MEP services, or maybe for the documentation part. Revit had an extremely good tools for the documentation. With the help of Civil 3D and Dynamo, you can completely share the information from Civil 3D corridor solids to the Revit families, right? You can exchange the information with the help of Dynamo. Right over there, you will get a beautiful a documentation part, or maybe you can do the detailed volumetric quantities for the structure team. For the team who is working with structure department, they can do rebar detailing, they can do tunnel analysis, they can do different types of simulations and stuff, and they can even extract the different kind of cross sections. As you can see, couple of snaps which I have added. This information has been exchanged from Civil 3D to InfraWorks. This kind of cross-section data you will get. This kind of corridor family you will get, right? This is one of the a small component part which has been captured by Mr. Shoaib. I think he would like to add some of the points. Shoaib, are you there?
Yes, Abid, I'm here. So
Yeah.
I think let me share my screen at this point.
Yeah, please.
So I think my screen is visible.
Yes, it's visible.
Okay. So like Abid mentioned that we transferred this data which we captured in InfraWorks, detailed that further in Civil 3D, and further we got those cross sections and redeveloped them in Revit. But to redevelop them, we used actually Dynamo to automate the process. So whatever data we captured in Civil 3D, or whatever data we detailed in Civil 3D, those cross sections are automatically created in Revit, and then further components were created out of those components. Then the purpose for bringing this to Revit was one of the part is documentation, like Abid discussed, and also to put up MEP services in it. So so we exchange data from Civil 3D, InfraWorks, and Revit. Then network design modeling was done in Civil 3D. We also did drainage and piping in it. And then in Revit, we added HVAC, electrical, plumbing, and firefighting components.
Here,
And also
Shoaib, I would like to add
Yes.
some points. So, as I mentioned earlier, also we can do the documentation in Civil 3D, Civil 3D as well. For the infra team, for the infrastructure sector, you can extract different types of cross section. You can do the documentation in Civil 3D. Further, when we exchange the complete information to Revit, with the help of structure team, Shoaib is from structure team. He had did a good kind of modeling in terms of rebar detailing and stuff. Apart from that, he also proposed some flood simulation structure. I believe he's covering in upcoming slides as well. So for that particular part, Revit also had a beautiful documentation tools in it. Right, you can do the a detailed documentation part. You can do the rebar detailing, and you can extract different types of cross sections. For that particular part, we have used Revit for the documentation.
Yes, like you mentioned, Revit only had this limitation that it has a limited extent, that you cannot create anything which is beyond 20 miles. Other than that, and I think 20 miles is very large, it is around 33 kilometers. So most of the time, it is this large of a project is not required to be developed in Revit. So, but otherwise, any type of detail can be developed in Revit because it's a multidisciplinary software. So I'll take you further. So these are the services which are placed inside the tunnel. So Abid will show you the entire walkthrough video of this project also. So this is one of the views from inside of the tunnel where you can see, ceiling lights, jet fans for ventilation, cable trays for electrical layout, handrails for protection, footpath, lighting fixtures, SOS phone fixtures, fire sprinklers, pollution sensors. There are many things which were placed here, like speakers and cameras and speed signs. So all of these were added. Most of these were added, actually developed and added in Revit, and then transferred back to InfraWorks. This screenshot is taken from InfraWorks. So this is the part where so tunnel has, this tunnel had, two sections. One is cut and cover portion at the exit and the beginning of the tunnel, and tunnel cross section was circular, which can be seen in the last slide. That, as you may notice, this is the cut and cover portion, which is rectangular cross section. And after certain while, I think you may notice that there is a circular variation, like tunnel is actually converting into a circular one. So that is the outer view of this tunnel. So what we did in cut and cover portion, this cut and cover portion was actually placed in a flooded region, actually flood prone area. So to avoid those extra flooding, we actually proposed some flood protection mechanism. So at the end of this cut and cover portion, and after every 10 meters interval, we have this cross sectional change here. So if I hide this particular portion, this is the cross section which is developed for flood protection. If I zoom it a bit, these are the details of this particular section. This is all developed in Revit. These are screenshots taken from Revit. So as you may notice here, under the road, there was this water tank proposed. It is about 5 meters of depth, and it has pipes running through these walls. So this is the civil part of it. There were pipes added later, which we didn't took a screenshot here. But again, so as you may notice, this is the shaft which is given for services. Pumps were installed in water tank, and pipes were installed here, and all of the water is actually taken out from the tunnel. So this is the flood protection mechanism which we did here. So I think this is the project walkthrough, which I think I would like to ask Abid to play.
Yes, sure. I'll share my screen. Okay, so this is, as I mentioned, we actually worked on a tunnel project, and this is the walkthrough which we have created with the help of a different kind of AC suits. So the area which you are seeing has been captured and modeled in InfraWorks. So again, I would like to add one more point. These days, a digital survey is also on a higher demand. So most of the government organizations are mandating the drone and digitalization survey. If I take an example of a particular industry in mining sector, it has been mandated, right? The point cloud information, the aerial information which you receive, you can replace the preliminary survey data which has been captured by InfraWorks with that point cloud information you have. You can overlap the aerial image on top of it, and you can further do a detailed kind of analysis and model. Because you have a detailed survey, detailed elevation information, you can, create more an accurate digital model, digital elevation model, I mean to say, right? Like digital project model. Apart from that, as I mentioned, we are worked for one of the particular project site, and these are these different kind of station buildings which has been modeled in Revit, and which we bring this particular project information to back to InfraWorks for the visualization part. The kind of information which you are seeing, the roads which has been modeled and proposed in InfraWorks, that information, like for the profile optimization workflow, we have exchanged complete information from InfraWorks to Civil 3D, or we propose the vertical alignment of that particular structure, right? Apart from that, as you have seen previously, our station building has been placed. That station component, station building has been developed in Revit, because InfraWorks have a data source option. And when you are working with Autodesk environment, you have a very good integration between the different AEC suite softwares. You can exchange information from one software to another, right? As I mentioned, InfraWorks have its own data source connectivity option. With the help of that, you can bring Civil 3D data to InfraWorks, Revit information to InfraWorks, and you can, because we are working in a coordinated manner, we are working in a geo-coordinated environment, right? You have a more detailed information comparatively a 2D based workflow, right? As you can see over here in this particular project, we have proposed two different types of tunnels. One for roadway, two for roadway, one for inflow, and one for another for outflow. And we have one for a railway structure. The project length is around 20 kilometers of rail and around 14 to 15 kilometers of roadway project, right? So with the help of InfraWorks and with the help of Civil 3D and with the help of Revit, we have developed complete model, and we took help from InfraWorks to create this kind of story or animation walkthroughs. So we have did a kind of a basic rendered in InfraWorks. Then, like, if you want to do a more further detailing, further rendering, you can exchange the information from InfraWorks 2 or 3ds Max, or maybe any of the other rendering tool. Again, you can do the detailed rendering over there. And as Shoaib mentioned earlier, the services which you are saving, these are the information which has been modeled in Revit, right? Our MEP engineer has developed all this information, and he has exchanged the information from Revit to InfraWorks. And this kind of walkthroughs and animations are something you can extract from the InfraWorks, right? Again, like, imagine in this way, if you have this kind of walkthroughs, this kind of detailing, this kind of 3D cross section ready with you, you can get easy approvals. And this is something also help you to increase your productivity in terms of design, in terms of cost, in terms of time saving, a lot of stuff, right? So with this, I would like to hand over session to Mr. Shoaib. He will share some of the workflow around the station buildings which we have modeled. Over to you, Shoaib.
Okay, thank you, Abid. So, like Abid showed the project here. So this is the entire project. This is the complete project which we developed in multiple softwares under AEC suite. So, and this final presentation was taken out from InfraWorks. So you already saw that station building inside this walkthrough. So that station building was actually developed in Revit, and it was developed by our civil team. So in this case, this is that just to reference that. So this is the screenshot from that video. So it's one of the proposed railway station at the end of the tunnel. So if I show you Revit here, so this is the same model. Thank you, sir. So this is the same model. In this model, and there are few changes which are here updated later, such as there were no solar panels added earlier on the roof of this platform and on the roof of this station. Later on, we also proposed solar panels here. So if I turn it into shaded, I think you'll see it in colors. And to install solar panels, obviously we would require the orientation of the of the sun. But before that, I would like to show you that detailed design can be done in Revit. So I've taken this example of this building because this is much easier to handle now. So there are few floor plans which are developed here, as you may notice here. So it is all developed here. So it's a kind of a working drawing, and it's a mirror image. So we actually show it by cropping this region, and that is the mirror image of it. So there are few elevations which are developed also. So such as this one, for example, there are levels which are marked here. So documentation part is also, and I think some of you already know about it, but some of you are also new to it. So that is why I'm just showing you the workflow. So further, quantities of a particular material or component can also be created. So for example, how many solar panels are placed here? If I need to count them, I can just leave this to Revit, because Revit is showing this data. Because once model is developed in Revit, it becomes a database, and the database can be extracted in the form of 2D views, 3D views, or maybe in the form of tables also. And this is the reason, this is the interface of Revit. Under View tab, it is kept. Schedules are also kept here, because for Revit, not only plan views or 3D views are considered views. Actually, schedules are also considered views, because for Revit it is all database. You can collect it in the form of table also. So I'll just create a schedule here for solar panels. Solar panels I have created actually in this category called specialty equipment. So I think I need to switch on other disciplines also. There's this infrastructure discipline which is also added after Revit 2020 version, I guess. So those who are not using latest version will be updated by this. Anyways, so I'm just taking up specialty equipment schedule here just to count how many solar panels are placed. I'll just get the name of the component. So maybe family and type, or maybe just type. I don't know. Maybe family and type, it's fine. I'll just take up other I think counts would be fine here. So maybe I'll just take up length and width of it if required. Anyways, not required for now. I'll just take up the counts of it. So you can just take up more options from the schedule. Who manufactured that solar panel? What are the details of it? What is the Omni class number for asset tracking added here? All of this can be added. So this is one glimpse of it, obviously. So there are different types of panels, and there are some other components which are also placed of the same category. So I'm just grouping it by family and type, and I'm just switching off itemize. So there are 60 solar panels which are added here. There were some doorbells also, bell doors, door closers actually added. So it is also counting them. So I'm ignoring it for now. But solar panels which are added here are 60 solar panels. And if I add or remove any component, it will also give us the count. Not only this, it will give me the quantity of the concrete used in it. Not only this project, you can also take up the tunnel project here and can get the quantities accurately. Anyways, how did I added these solar panels? I just placed them. But before placing it, I would require some, solar data. So to add sun data, we can go to, additional settings here. And I'm just, set up the sun. To set up sun, I actually chose the location of the project. So it is actually linked with this Microsoft service called Bing service, Bing Maps. You might have heard about it. So I searched for the location. This is the location where this project is located, and it has taken weather information from it. So setting up location is also setting up the weather information. These are different weather data, weather stations which are added, right? So I'm taking this weather station. So you may see this weather station is updated. This data is taken in 2006 actually. But again, these are the informations about weather stations. Accordingly, we can also set up the date for our setting up sun, and we can also set up the times. So in this case, for example, if I switch on shadows, just a minute. So just change the view for a while. Just a minute. Yeah. So I've just converted this into perspective view. Earlier it was this orthographic. In perspective view, you get better visuals, so that is why. And I'm just switching on shadows by this option. So it's a shortcut here to switch on and off shadows. So as you may notice, shadows can be simulated in this. So that we can identify the areas where sun might not be falling properly, right? So maybe I can turn it into site plan. And we can also check up sun during any point of time. So I'll just switch on sun path here. So I've just gone to the sun setting and added the time and location. I'm just switching on sun path. So this is the sun path which is added here. And if you move the sun, it can be physically interacted. If I move the sun manually, sorry, it updates actually, but this time I think there are some graphical issues. Anyways, further what you can do once shadows are on, let me turn it into hidden line so that we can switch off colors and can focus on sunlight. I think you can see the sunlight, the shadows now, and I can simulate it. So here we have the option to preview the solar study. I'll just play this, and as you may notice, as per the change in the location of the sun, shadows are being simulated. And I'm taking a zoomed out view. For example, if I zoom in a bit, you will see the changes live. For example, if I go to this particular region, so for example, I need to study. So I'm very much clear about these solar panels which are installed on the roof of the station, but I'm not very much sure about these solar panels which are actually placed on the roof of the platform. So if I need to simulate sun study again, so I'll just switch on preview and run it. So as you may notice here, this region is not getting enough sunlight during the day. I'm talking about this region, right? So if I again simulate this here, you are seeing that these 3 to 4 panels are not getting sunlight properly. So to optimize the resources, we can simply remove panels from there. Right, so this way you can before installing any component on site, this is one of the example. It is true for any kind of component, that before installing it on site, you can just simply optimize your resources also. So for example, these 4 panels, in my opinion, should not be placed here. I can just simply remove it and can send the proposal to site, right? So anyways, so I hope you got the basics of it. And just a minute, I'll switch it. Obviously, you would require some good graphics input from here. Yeah. Okay, so that was all from my side. I would like to invite Miss Riddhi Bhatia for taking up all of this on Autodesk Construction Cloud, and to give us overview about Autodesk Construction Cloud. It's a cloud service from Autodesk side. So Riddhi, I think over to you.
Yeah, thank you, sir. Let me share my screen.
Yeah, sure.
Okay. Sir, can you confirm it's visible or not?
Yeah, your screen is visible to us.
Okay, thank you. Okay, so Autodesk Construction Cloud. So it's a cloud-based platform which is used for construction management and collaboration solutions. So this platform, there are 3 major offerings under ACC, which are BIM Collaborate, Autodesk Takeoff, and Autodesk Build. So all these different tools are used in different phases of construction. So starting from the design phase, BIM Collaborate is used. And then for the pre-construction phase, Autodesk Takeoff is used. And then during the execution phase for the project management, Autodesk Build is used. Then there is Docs, which is utilized as the common data environment. And Docs unifies all the 3 offerings of ACC, since all the information we are storing in Docs. So from Docs only, these tools are acquiring these information about the project. Then there is Insight. So Insight delivers analytics in the form of dashboards, reports, and it actually uses the project data which we are adding to the cloud and give the analysis. And it also has construction IQ, which is the artificial intelligence. This artificial intelligence identifies and help in mitigating risk priorly. Then we have the administration. So administration provides the centralized user and permission management. So we are adding different teams to our cloud platform. To secure our data, we need permission control. So all that is handled through administration. So administration is also used for project setup, and it's a single authentication platform for the unified products. So the docs is the document management part of ACC. So docs is available as a separate product and as well as with the other offerings of ACC we have just seen. Okay, so when we say we can do document management on cloud, it's just not mean that we are only uploading files on the cloud. But here in docs, we can perform document control, document versioning, document approvals. So if we look in detail, what is document control? So document control, all the files we are sharing on the cloud, these are uploaded in a structured folders. Okay, so these folders have permission control. So not all the members which are added to the project will be able to access all the files which we are uploading in different folders. So we are making folders discipline wise. So in the similar way, we are providing permissions to different members, different permissions level to different members to each folder, so that we can make sure that right information is in the right hands. And also at the same time, all the project members have complete information about the project. So if we go to document versioning, so since we do revisions of our files, files which we create in authoring tools, we revise it time to time. So all these revisions we make to different files, we can instantly recognize and by comparing the two revisions of the file. So we need to make sure that the team is working with the latest information. So for that, the latest revision should be highlighted, and we should be know that what changes have been made as compared to the previous version. So what has been added, what has been modified, what has been removed, all that information about the document, about the latest document can be recognized easily. Okay, so all this information can also be exported in a form of report. Then there is document approval. So document approval here in cloud, we can use it to replace the manual process of getting your documents approved. So with this automate review and approval process here in docs, we can get our files approved automatically, and we can create a approval workflow here with the customized steps. How many reviewers you want, or who all will be the reviewers. With the time limit to each reviewer, you can create a review approval workflow for the files, so that only the approved files can go to the construction sites. Okay, now let's see how to navigate to the platform. Okay, so Autodesk Construction Cloud platform, we can open it in the browser. So by searching acc.autodesk.com, we need to then log in our credentials, and then it will be land to the list of project page. Okay, so you can control many projects with the same account. So all the projects belonging to your organization will be enlisted there, and so among that list you can choose the project you want to work on. Also only that projects will be visible to you which you have been added by your organization. Okay, now we need to bring members so to the project. Now members tools here in docs, it enlists all the members which are added to the project. Okay, so all the information about the members will be highlighted here. You can add new members and then specify their IDs, the email IDs and the company details, and then give them the access to the product. So based on their role in the project, they will be given the specific product. They will be assigned to that specific product. Okay, so now after the team members of different stakeholders have been added to the project, now we need to set up the project. So setting up project, we will be creating folder structure. So these folders will be discipline wise and as well as project phase wise. Okay, so the folders in these folders, you will be doing the permission control. Okay, so all the members which are added to this project will be assigned to different folders and with the different permission level. So let's say there is a folder dedicated to the architectural drawings. Then there is a folder dedicated to MEP drawings. So members belonging to the architect team will be given the full control to that folder, while members belonging to the MEP team will maybe given the permission of view or download. Okay, so in this way we can control our files to permission control. So let me just forward move it. Oh, 1 second. Yes. So you can see here different members have different permission levels. Moving forward, 1 second. Uploading files. So now we have set up our project. We have created the folder structure. Now we need to bring our project files to this platform. So the platform supports 60 plus file formats of both 2D and 3D. Okay, so when we say that it supports 60 plus file formats, it means that we can actually view our 2D or 3D files like for Revit or Civil 3D or Navisworks on the cloud platform itself. Okay. So here you can see the viewing of files in the cloud. 1 second. So we have different tools which will help us in better viewing and navigation of files. So here we can orbit around the model, your BIM models. You can zoom in and zoom out, view them in section along X, Y, or Z axis. You can measure distances, angles, and areas in the model. And then you can also know the properties of the elements used in the model. So like you have viewing experience in your authoring tools, similarly using viewing in levels or measuring the model and even knowing the properties of the elements. So all that you can just do it on the cloud. So only the viewing part, not the editing part. For editing, you will be needed to download the model and then edit it in the authoring tool itself. Okay. So we can also what we can do, we can compare different versions. So while viewing, we may come across some changes which we need to do. So for that, we go to our authoring tool and make the changes, and then we need to import that model back in the cloud. Okay. So this is one way. There is also a collaboration features in the various authoring tools like in Revit or Civil 3D and InfraWorks even. So this collaboration features allows you to directly upload the updated model onto the cloud. Okay, so it will come to the cloud with the version update like V1 or V2, and then you can also other person, the other team member can compare what has been updated. Okay, so there are various methods of comparing your files. So using side by side comparison or even overlay comparison, you can compare the two versions. So you can see here the version V2 is the maybe the latest version here, and this is the current version. So this is the previous version. Now you can compare the two versions. One second. Sorry.
Thank you, Riddhi. With this, I
Wait,
would like.
wait, actually,
Okay. Sorry.
let me go. Okay, so there is issue management in docs. So it's the other aspects of the tool. So while viewing your drawing in or the model, so you can actually increase the communication with teams using the tools like markup and issues. So an issue here we uh, any issue we come across while viewing the drawing, we can just highlight it there in the drawing itself. So there are some pre-configured categories of issues, as you can see here. We can choose among these and tag it here in the drawing itself. And then we can add the description of the issue. We can add the assignee whom we want it to resolve the issue. And then we can also attach references. So references can be in the form of photos or maybe some files which we want to be attached to that issue. So we can do here, and also we can give the due date to the assignee to resolve the issue. So how that will be help? It will help the people at the manager level to know which issue has not been resolved yet, and help in resolving issue quicklier and priorlier, which before it goes to the later stage, and maybe reduce the rework. Okay, so all these issues which we are creating in the project, it's enlisted in the issue log, and then you can even extract a report out of it. So like you can create a report of all the issues in the project which are overdue. Okay, so you can filter by choosing the due dates, and then it will generate a report containing all the issues which are overdue. Okay, with the attachment whichever you have added to the issue in will also be there in that report. So all this data here and there which we are creating in the cloud in the project will help in judging the quality of the project later. Okay, so through these reports and dashboards in Insight tool, we can know the health of the project. We can judge the quality of the project. Okay, so there is another tool, transmittals. So it's a way of e-transmittal. So we can formally send our files to another project member or team through this tool. So you can just choose the number of files you want to share, and then you can send by creating transmittal. You need to add the recipients, and then it will be shared to them in the form of email. They will be receiving the list of files, the transmittal through email. Okay, and for your record, all the transmittal which you have created through this platform, it will be enlisted in the transmittal log with the details of the sender or receiver, and the files which you have sent through that transmittal. So all that information will be, you can refer later through this transmittal log. Okay, so this was all about the document management part of ACC.
Oh, thank you, Riddhi. Thank you for sharing. With this, I would like to share my screen. I just want to show the workflow which Riddhi has explained. Even we have used ACC for the collaboration part. As I mentioned, we have MEP and we have an infrastructure team. So Mr. Shoaib is from the structure department, and Tanvir, we have our colleague. He's working on MEP stuff. So we took uh, uh, ACC for the platform to collaborate and work on a single source of platform, right? You can see these are the different kind of file structures we have internally planned. In MISC inputs, we have our Rivet information data and InfraWorks. I have published my InfraWorks model to this particular size. As you can see, the 3D models, the libraries which we have specially created for this particular project has been published in the docs. So being as we have a common source of platform, common environment data, multiple organization or multiple internally people can collaborate on a single source of platform. If for an instant, if I open InfraWorks model, the people from the higher authority or maybe from the people who are working in a site without having their softwares installed in their systems, they can actually view the model and they can create issues, transmittal as earlier Reddy was showing. If there is a particular issue which you want to identify and which you want to rectify immediately, you can directly the people from the site or the people from the project execution department, they can directly create issues and assign that particular issue to the respective design consultants. Or maybe as in this particular webinar, we're actually pitching towards the sustainability without having a paper, without having any kind of paper. You can actually work with the help of this kind of 3D model. So there is a project already has been executed in other countries apart from India. They have actually drafted and extracted different kind of 3D cross sections for a bridge project, right? Without wasting up a single paper, without having a single document printed on a paper. They have completely executed entire project on the cloud, right? So as you can see, I have published the InfraWorks model. Earlier also I'm showing the same kind of model. You can actually weave that InfraWorks model in a laptop or maybe a mobile tab. You can open, weave, create issues, and you can exchange the information between the project team to the design consultancies. If you arise any issues, you can directly raise a ticket at site that a respective authority person will resolve then and there. So because of due to the common data environment, we can collaborate more accurately. With this, we would like to move towards the Q&A session. And then we can conclude this particular session. So meanwhile, if you have any questions related to this particular webinar, you can post it on the chat box. We'll be happy to answer those questions. Stop. Yeah, there are a couple of questions. Someone posted why BIM not used in infrastructure. So, sir, I would like to answer this question. BIM is widely used in infrastructure project since a few years ago there was a the project is me itself. When we are working with a consultancy firm, government has itself stated that if the project cost is more than 400 crores, you must need to submit a BIM model. Now we are I'm giving a random figure, it may not be accurate, but in India also extensively we are using BIM. If I take an example, DMRC is also working on this particular platform only. They are adopting BIM for their for phase 4 project. If I'm not wrong, correct me, Shoaib. They are using for phase 4 project as well. So I believe there is a lag. We have we are completely not adopted the BIM, but yeah, industry is rapidly moving toward the BIM implementation. Even Capricorn itself work with many of the consultancy firms, and over there also we are working for the implementation part. As I mentioned earlier, we recently started working with one of the firm for hydroelectric project as well. Over there we are implementing the BIM for their hydroelectric projects. Even Capricorn helped a lot of organizations to adopt BIM in their infrastructure projects. So there is one more question. I think InfraWork is not workable in detailed design stage project due to level variation. Absolutely, sir, you're right up to a certain extent. We can't use InfraWorks for the detailed design, but when you are in a preliminary stage, you can actually take help from the InfraWorks to capture the site conditions, terrain conditions, right? As we have a preliminary level of analysis information, you can work in detail. You like further, as I mentioned also, if you have a digital survey information, you can bring the digital information to InfraWorks for the visualization part, for the documentation part. Like whatever the information which you have captured in InfraWorks, then you can exchange that information to Civil 3D. Over there, you can do a detailed design, detailed documentation, and further more details. You can exchange the information from Civil 3D with the help of Dynamo. You can exchange the information to Revit as well, or maybe you can even bring that InfraWorks information to Revit for the detailed design workflow. Yeah, there is one more question I would like to answer. How can we create a corridor with tunnel assembly in Civil 3D? So like there are country specific country kits which are available. If you install India specific country kits, you will find couple of tunnel assemblies. Apart from that, I also believe that there are numerous different types of tunnel projects. According to project requirement, we have to model a cross section, or maybe I should say a sub assembly, right? So Civil 3D itself have a sub assembly composure with the help of Visual Studio, with the help of visually impacted tool. You can actually take help from Civil 3D sub-assembly composure. You can build a detailed tunnel model over there, and that tunnel assembly you can bring into Civil 3D. Even the assemblies which you are seeing in Civil 3D has been modeled with .NET wireframe, but with that, when you install Civil 3D, you'll also get Civil 3D sub-assembly composure. Using that Civil 3D composure, you can model a more detailed or complex sub-assemblies. You can bring that information to Civil 3D and you can run as a corridor, or run on top of an alignment to build a corridor. There is one more question. How do you make sure the building orientation and coordinate match with the actual site location in InfraWorks? I mean, how do you place the Revit model in the InfraWorks in the correct geolocation? Okay, correct me, Shoaib, if I'm wrong. In Revit, we have a option called acquire coordinates. For that
Yes,
part,
we do.
yes, right? So yeah, there are multiple ways to bring the information to InfraWorks. See, the only condition is you must need to have a coordinated model. For an example, if I take an example of a site we have in Civil 3D, in Civil 3D, you have an option to, exchange the information. You can publish the surface to Revit. Within Revit, you can bring that topology with the help of topo surface, and you can acquire the coordinates over there. So when you have acquired coordinates, you have real world coordinates. When you exchange information from Revit to InfraWorks, that building actually hold true northing and easting values, right? So that true north and east, according to that true north and easting value, you can actually place that particular site on the model. Apart from that, there are multiple other ways also.
Yeah, so I think I would like to add here. So
Yeah.
whenever you would like to bring any component from Revit to InfraWorks, workflow should be that you capture data from InfraWorks and bring it to Revit. That will be a coordinated data. Or maybe like Abid mentioned Civil 3D, so you can take that data in Civil 3D and then further can be linked in Revit. Revit has this option called acquire coordinates. Under its coordinates option, you can just simply acquire those coordinates from the Civil 3D surface or maybe from InfraWorks data, and then model can be placed with the help of site points such as survey coordinate system, and one is known as project coordinate system. You can just place it on the surface which is taken from Civil 3D or InfraWorks, and then later on that can be further again linked back to InfraWorks again. So that is one of the ways. Like Abid mentioned, there are other ways also. So you can also manually place it whenever required. But yeah, if it's a coordinated model, then Revit will automatically grab those coordinates. Okay, Abid, you can answer other questions, I guess.
Okay, there's a question related to data loss. So you're working in a Autodesk connected environment. Most of the time, InfraWorks and Civil 3D have a very good data exchange platform. Since 2018 release of version, like they specially developed a plugin within Civil 3D. So when you install Civil 3D, by default, you'll get a ribbon in InfraWorks, ribbon with the name of InfraWorks. So, InfraWorks, Civil 3D have a greater collaboration platform. You can exchange any kind of information between Civil 3D to InfraWorks without any information loss.
And
Like
further,
it
I
is,
would like
yeah.
to, okay, sorry. You can complete your answer. Sorry.
No, you can
Okay.
elaborate further. Yeah.
Okay, so further, I would like to add here that now in newer versions of Revit after 2020, it also get good collaboration between Revit and Civil 3D as well. So Civil 3D would be the nodal point for both InfraWorks and Revit. So whatever data needs to be exchanged between Revit and InfraWorks, there might be some data loss, but it is recommended that you bring it through Civil 3D. And Civil 3D would be the software where you can detail both InfraWorks components and Revit components as well. So and that is how we did it this in this project also. Okay, Abid, over to you.
Yeah. If you have any other questions, we'll request the audience to post it out on. Otherwise, we can conclude in 30 seconds.
I request all the candidates to put in their questions, or then we'll conclude the session. Okay, I guess there are no more questions on the topic. Thank you so much, Shoaib, Abid, and Riddhi, for such an insightful session. We'll head towards the conclusion of our webinar series. With smart infrastructure, we are shaping an ecosystem that connects real world with the digital world, making it more greener and sustainable. Together, we are trying to transform our everyday for a better future tomorrow. With that, we would like to close the session. Thank you so much, everyone, for attending the session. Thank you so much.